49 is on distance versus displacement and velocity versus speed. Okay, so we've talked about this a little bit before, but not a ton. So I don't know. So we'll kind of, at the very end, I'll review some basic concepts that are going to help you on your homework because some of the people forgot like what we had talked about before. So anyway, so a distance is a scalar measure of the interval between two locations measured along the actual path connecting them. So distance, the thing to remember is that it's always positive, okay? Okay, but the displacement is a vector measure of the interval between two locations measured along the shortest path connecting them. So it's basically like you're connecting the starting position to the ending position and just finding that distance, okay? So that can be positive or negative. So the best thing that I always have found is to talk about, my cross-country team. I've told you this before. If my cross-country team runs out 3 miles and comes back 3 miles, they've covered a total distance of 6 miles because they've gone positive 3 and then the negative 3 is an absolute value is another positive 3. So it's going to be a total of 6. But their displacement, how much they've moved from the starting position, ends up being 0, which they don't like when I say that their displacement is 0. I think they would like to hear that they ran 6 miles, right? So yeah, that's the basic example if you guys think about that. So the equations are that the distance is equal to the absolute value of v of t integrated, and displacement is no absolute value because displacement can be negative, okay? So number 1, if an object moves along a straight line with velocity v of t equals t cubed plus 3t squared, find the distance traveled between t equals 1 and t equals 4. So since we're saying distance, we know that the distance is going to be the absolute value of the velocity function. So we're going from 1 to 4. So on your AP test, I would always write it in the simplest form possible. This is the most concise, simplest form possible, okay? If you want to, you could write it like absolute value of t cubed plus 3t squared. Just be careful because sometimes when people are in a rush, they leave off an exponent or whatever. And you don't want to make that little error and not get a point for your setup. So, all right, so since this is an absolute value, we did absolute values yesterday. So we want to think about t cubed plus 3t squared, where it's positive and where it's negative. I think it's positive everywhere. But you can sketch a little rough graph. You can use your calculator if you want to. It would definitely go through 0, 0. Let me do I don't have my calculator open. So go ahead and graph it for y equals. But I think on that interval, it's always positive, right? Because you're plugging in 1 to 4. Doesn't it make sense? There's no minus in the equation or anything. Did you get it? So we have that. So if we're integrating, what we could do is we could put the absolute value here if you want. So you can do number, absolute value. And then you can go to your main screen and you can do math 9 and then vars, y vars. Now that you have the absolute value in there, it's already in there, comma y1, or y1, and then comma x1 to 4, okay? So you could do that. So you get 126.75. Okay, but if you were doing this by hand, basically this is the same as if you just remove these absolute values, because we just showed that it was always positive on that interval 1 to 4 anyway. Does that make sense? All right, so the next one. So it says a particle moves along the x-axis with velocity v of t equals 6t squared minus 18t plus 12. So now it says compute the answers by hand, and then you can verify with your calculator. Okay, so it says find the total distance. So distance is going to be the integral of the absolute value of v of t dt, and we're going from 0 to 4. Okay, so when we do this, we need to actually graph 6t squared minus 18t plus 12. And the most important points we talked about are the zeros, the x-intercepts. So if you pull out the 6 and factor, you have t equals 2 and t equals 1. So that means we have a parabola that's crossing at 1 and 2. And we know it's an upwards parabola because it was positive t squared. So it looks something like that. So on our graph, we have the absolute value of that. So the two portions that were positive y values stay the same, but the part that was in the middle that was below the x-axis, that flips over. So if we're finding the integral from 0 to 4, we're finding this little, kind of like a triangle there, and then this portion, and then going all the way to 4. Okay. So we're finding those three pieces. So we're going to do three integrals. So I'm going to do from 0 to 1, and that part was already positive with the v of t. So we're going to do 6t squared minus 18t plus 12. And then we're going to say, well, we also have 1 to 2, but that part was below the axis before, so we actually have the opposite of v of t. So it's up to you. You can put the negative out front if you want, and then just write positive 6t minus 18, or positive 6t squared minus 18t plus 12. Or if you don't put it out front, then just put it on the inside. It doesn't matter to me, whatever you want to do. All right, and then the last part is going to be from 2 to 4. And that's going to be the positive one again, because it was already positive. We didn't have to flip it over. It's kind of like the part that was negative, we need to do another negative to make it positive, right? Okay, and then we can find our answer. So I'm not going to waste too much time. You guys know how to integrate that. Like you could integrate it and you'd have 2t cubed minus 9t squared plus 12t going from 0 to 1 plus the rest of all of that. So you can do that. But I'll let you use your calculator on this. So go ahead and quickly put it into your calculator. All right, anybody get it? Comes out nice, very nice. It's all 34. So all of it equals 34. All right, did you guys get that? I just went ahead and did the absolute value. All right, so when it says find the displacement, those ones are the easier ones. Okay, displacement, you never have to worry about where it was positive and negative and so on. Displacement, you're just finding the integral of v of t dt. Okay, which is much easier to do by hand than distance. So we're going to do 0 to 4, and then we're going to have 6t squared minus 18t plus 12 that we're integrating. So we get 2t cubed minus 9t squared plus 12t going from 0 to 4. Okay? And you can find this. It's not terribly difficult. 4 cubed is 64, so 2 times 64 is 128. 4 squared is 16. 16 times 9, do you guys know that? No, no one. Crickets, 144. And then 12 times 4 is going to be 48. And then the rest of it is kind of nice because it's all minus 0, right? We like that. So if you do 128 minus 144 plus 48, so what's 128 plus 48? 176. Then you can do all of that without a calculator. Okay? All right, I didn't put any units. I really should. It should be like meters or feet or something. I didn't do it. All right. So for the following problems, the velocity is given. Find the distance and the displacement for the given time interval. Okay, so if I was doing this one with no calculator, I'll kind of show you the setup. So again, you would have to do the y equals t squared plus t minus 6, and you'd have to factor it to find its zeros. So you'd get t equals 2 and t equals negative 3. So we graph it. So we have 2 and we have negative 3. And then we know that they're going up. Okay, so if I'm going from 0 to 3, this part that was below the axis now gets flipped above when I do the absolute value, right? So if I'm doing the integral, maybe I should write out distance so you don't get confused. This is the distance. The integral of the absolute value of v of t dt. going from 0 to 3. So we'd end up having the part from 0 to 2, and then a little bit going to 3, right? So we'd have 2 pieces for our integrals. So the first part was the opposite of v of t, so negative t squared minus t plus 6. And that part goes from 0 to 2. And then the second part was our normal v of t equation, t squared plus t minus 6, and that was going from 2 to 3. Okay, and you could find that. I'm not going to waste too much time doing that. So let's go ahead and I'm just going to put it in my calculator really quickly and get an answer for you guys. Okay, so when you do this, you should get like 10.166. Okay, and my calculator, I believe, has done a rounding error because it says 10.1666853. Okay, I'm guessing it was 10.16 repeating. Okay, so if you're not sure, then on the AP test, do 3 decimals and you're good to go. Or you could do it by hand and see what the actual answer is. All right, displacement. So displacement is exactly the same thing. There's just no absolute values. So you're going to have v of t dt. That would not be hard to do by hand. On my calculator, I'm just going to remove my absolute values. And now I get negative 4.5. All right, so the question is, a lot of times I make problems where and the AP test does this too, where it talks about initial position. Okay, so if you started at 10 units, and I asked you, so I said the starting position was 10 units, what is the final position? How would you find that? Yeah, the position after 3 seconds. So you would take the 10, like what are you adding it to, distance or displacement? Displacement. Does that make sense? So if you started at 10, and in the end, your total movement is backwards 4.5, then you're really going to be at 5.5. Does that make sense? Would you guys be able to do that on the homework? Yeah, you have a couple like that. Okay, so let's skip number 4. I think you guys kind of understand the concept. All right, so this one is a non-calculator one. So sine and cosine aren't too bad to do without a calculator. So if I have v of t equals 2 sine of t plus 1, the hardest part about this is knowing what the graph looks like. Okay, do you guys all remember from pre-calc what this looks like? Some of you that have it fresh in your mind from summer pre-calc. Yeah, it's going to look like the sine function. I see you guys kind of drawing out the sine function. But the plus 1 means that you've shifted up 1. So your new axis, I guess, I call it the equilibrium line, is at 1. Okay, and you're going to go up and down off of that line 2 units. Do you guys get that? Because you have an amplitude of 2. So you're going to go up like the sine function, down, and then back through. And we end at 2 pi. So if we're finding the distance, we have to do the integral of the absolute value of v of t dt from 0 to 2 pi. But it's a little bit weird because the absolute value means that we're going to flip this little part. Oops, I think it goes all the way up to that 1, right? We're going to flip it up here. So we're going to have that. We're going to have this little triangular portion that's not really a triangle. And we're going to have this portion. So we're going to have 3 pieces. Okay. So if you didn't have your calculator, you would have to do 0 to something. Uh-oh. We need to find what this point is and what this point is, right? So how do I do that? No guess and check? No. Set what? You guys are very non-specific. Set it equal to 0. Set what equal to 0? Set your velocity equal to 0, right? So your velocity 2 sine of t plus 1 is equal to 0 when sine of t is equal to negative 1/2. Okay, and this is why when I teach pre-calc, I drill this into people. I make them use the unit circle. I want them to know these really, really quickly. And I think you guys do. I think you guys are good at your unit circle. Maybe. Are you guys good? So sine is the y value, so it's saying where is the y value equal to negative 1/2? So what are our 2 values? 7 pi over 6 and 11 pi over 6. Good. Did the rest of you guys know that? I keep saying I need to do a random unit circle quiz just to see if you guys are on your toes.
I know.
All right, so we do 0 to 7 pi over 6. And that's going to be our normal 2 sine of t plus 1. And then we do our 7 pi over 6 to 11 pi over 6, and that's the opposite. It's negative 2 sine of t minus 1. And then we add that to 11 pi over 6 to 2 pi, and then 2 sine of t plus 1. It would never be this long, don't worry. It might be 2 things at most. All right, and then you would integrate. So if you were integrating, then you would have, let's see, 2, the derivative of sine is cosine, so the integral is negative cosine plus t, and you'd go from 0 to 7 pi over 6, and then you'd have the next one, and you'd have the next one, right? I'm going to skip it. Can we handle that? Okay, so if I put this into my calculator to find this answer pretty quickly, just make sure you're in radian mode when you have sine and cosine, right? You should always be in radian mode. All right, did you guys get an answer? What'd you get? Anyone? No one? Did you get 14 something? I feel like this wasn't the same answer that I had before, so now I'm worried. Oh, maybe, hang on. I think I might have missed my parenthesis. Hang on. It takes forever with the absolute value. What'd you guys get? No one did this. 9.023 is the answer. So that's the distance. Did you guys get that? All right, and then the displacement, just remove that absolute value. So you're going to have v of t dt. This one would, like I said, would be much easier to do by hand because it's only one integral. And that one's going to be 6.283. So I think my calculator did have a rounding error because it says 6.283185307, but I think it's really 2 pi. Actually, that is 2 pi, so we're good. So yeah, if you're not sure, just do the 3 decimals. Okay, we got that down? You understand that? Okay. So same thing with speed and velocity. So speed is always positive. Velocity can be positive or negative. Okay, so velocity indicates a direction. So if I'm going negative 40 miles per hour, then I'm going backwards 40 miles per hour. Does that make sense? Okay, so speed is just the absolute value of velocity. And they will try to trick you a lot on the AP test by talking about speed. So let's say we have a very complicated equation. It says a particle moves along the lines in such a way that at time t, where t is between 1 and 8, its position, right, so don't get confused by s of t, that's just position. Sometimes we use x of t too. Is s of t equals the integral from 1 to t, a bunch of stuff, right? It's pretty scary when you look at it, right? Because you're like, oh my gosh, do I have to integrate this? You do not have to integrate this. Okay, so A says write a formula that expresses the velocity of the object at time t. So if you have the position and you're trying to get the velocity, what do you need to do? Yeah, you're just going to take the derivative. Well, how do you take the derivative? How do you find s prime of t? How do I take the derivative of this? The derivative of the integral, what's that called? It has a special name, a very important name. The Fundamental Theorem of Calculus. The most important Fundamental Theorem of Calculus? You don't think that's important? It's the Fundamental Theorem of Calculus, right? So basically, you're taking the derivative of an integral, right? You don't have to write all this out. I'm just going to write it out for your notes. So we have learned that what we do is we just take this t and we put it in, right? What if it had been t squared? What would I do? I would put in t squared, but then what do I do at the very end? I would multiply by 2t, right? So the derivative here, s prime of t, in other words, the velocity, is going to be 1 minus t times cosine of t minus natural log of t times sine of t. So write that part down. That's what it is. Which is still a bit frightening. A little bit scary. It's all right, we got this. So that's our velocity function. So part B says, at what instant does the particle reach its maximum speed? There are multiple ways that you can do this. We know that in calculus, when we say maximum, we often have to take the derivative, right, and find when it's equal to 0 or undefined or whatever. But if this is a calculator problem, which it is, how do I find the maximum speed? What's the easiest way? You're not being very specific again. Plug it in. Plug what in? S of t, v of t. Yeah, can you make it even easier instead of doing v of t? What do I do for maximum speed? Absolute value of v of t. Okay, so you're going to go into your calculator. So I'll do it along with you. So everybody do this with me. Of course, it's not clearing. Okay, it's not doing anything. Great. We'll use another one. All right, we're going to put this in for y1, but we're going to actually go ahead and put in the absolute values. Okay, so we're going to do math number absolute value. 1 minus x cosine of x minus natural log of x times sine of x. All right, so I have everything and it's in absolute values and everything. So when I'm not going to quite hit graph yet. What should my window be? At least for the x's. What do you think?
1 to 10.
Nope. Look at it. 1 to 8, right? So since you only have 1 to 8, I would make your window 1 to 8. Just so you don't see anything that you're not supposed to actually use in your answer. All right, so then we hit graph. It goes kind of slow when there's an absolute value. So if we're finding the maximum speed, we're basically finding the highest point, right? So the t value, it says at what instant, at what time. And so you're comparing these two heights. This second one looks higher, right? So we do second trace maximum, and we just find it. So don't overcomplicate things. Don't like think, oh, this is calculus class. It says maximum. I need to take the derivative, set it equal to 0. If it's a calculator question, use your calculator. Unless it's a really easy derivative to take, and it takes no time. All right, so we get 6.700, and the y value is 5.896. So when it says at what instant, that's the t value. That's your time. If I said what is its maximum speed, that would be the 5.896, okay? So I typically will go back to my main screen, and I'll do x, and I'll store it just in case I need it, because oftentimes on free response questions, you will need it. And I always store the y as well. So if I do alpha y, it pulls up that y value from the intersection. So I'm going to store that as b just in case I need that. Okay, so at what instant does it reach its maximum speed? It reaches its maximum speed at t equals 6.700. Is that what it was? All right, so when is the particle moving to the left? So how do you think we do this when it says moving to the left? Do I do my speed? No, I do my velocity, right? You want to find when your velocity is negative. So you want v of t to be less than 0. So when you go into your function, what I would just do is I would remove the absolute value. So to do that, you just hit delete on that first arm. And then you go to the very end and remove that last parenthesis, and I think it's fine. Actually, maybe it removed that already. Let's try. Let's try to hit graph. Okay, now it's going to show you the part that went below. Okay, so it's moving to the left from whatever this x value is or t value to 8. Do you guys all see that? So how do we find this this little point right here? The x-intercept? You guys remember? Yeah, second trace is 0, right? So when we do 0, we're going to do left bound, so we get on the left side of what we want. Right bound, get on the right side of what we want. Guess, I usually go to right where I think it is. Hit enter. So we have 5.204. So it's going to be on the interval (5.204 to 8). Okay, don't go further. Don't say to infinity. Okay, because you only know it's happening from 1 to 8. And then find the total distance traveled. Well, our distance is going to be equal to the absolute value of the velocity going from 1 to 8. So you can put the absolute value back in on y equals, but I would probably just do it on the main screen. So I would do math 9. I would do 1 to 8. And then I'd put in the absolute value. So I do math, go over to number, absolute value. And then I don't want to type in all of y1 again, right? That would be complicated. So remember, we have vars, y function, y1. A very handy trick. It also helps if you have lots and lots of parentheses. It's really helpful. All right, then hit enter. Anybody get it already? Very speedy. Mine's really, really thinking. Absolute values, man, they really mess it up. Yours are thinking too? We're just waiting. Do, 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 do. I got nothing. 21.461. All right, not your answer. Okay, does that whole question make sense? You guys understand that? Okay, so we're not totally done because I told you that for some reason the homework that I assigned, I involved a lot of things that we did before. So with Fundamental Theorem and so on. So I want to show you a couple examples of what might be on your homework because they don't totally correspond and it was leading to some confusion in the last class. Okay, so let's do a couple extra examples. You can flip to your additional notes if you want to. So let's say your velocity function is given by 5t cubed minus 2t plus 3. I'm just totally making this up. Okay, and your initial position is s of 0 equals 10. Okay, I want you to find v of 4. Okay, that's the first thing I might ask. Find v of 4. Okay. Oh wait, initial position is that what I want? Yeah, okay, v of 4 is easy. Okay, what do I do for v of 4? I'm not really making this complicated. You just plug it in. So you have 4 cubed minus 2 times 4 plus 3. 315. All right, what if I wanted you to find s of 4? Okay. Yeah, so Jamie's realizing that you need an antiderivative. Okay, so you can do the antiderivative of the function of the v of t, but then the nicer way to write it, though, is to recognize that you have an initial position. So you have a certain x value, x equals 0 or t equals 0. And that you have the t equals 4 that we want, right? So what we're going to do is we're going to go from 0 to 4 of our velocity function because we know by that second fundamental theorem or first fundamental theorem, whatever, that we're going to have, not v of 4, sorry, s of 4 minus s of 0. Do you guys understand that? Because when we integrate velocity, we get position. So the 0 to 4 v of t dt, we can actually just get on our calculator. Okay, so we're going to do math 9, and we're going to do 5t cubed, or 5x cubed, minus 2x plus 3. And we're going to go from x equals 0 to 4. So when we do that, we get the very nice 316. But we have to remember that our initial position is 10. So what happens is you take the 10 and you add it to 316. So you get a total of 326. So can someone explain, using terms that we learned in this section, what we just did? What did we find here. We found, what word starts with a D? We found displacement. We found the displacement from 0 to 4. So why did I have to add 10 to find its position at 4? Right? Because it started at 10, and if you move to the right 316 units, but you're already at 10, then you're really going to be at 326 units. Does that make sense? So you always have to think about that. Okay. What if I wanted like the acceleration at 4? What would I do there? Yeah, you'd find v prime, which is going to be your acceleration, right? So you would find 15t squared minus 2, and you would plug in 4. Is that 180, 16 times 15? No, 240. Okay, 240 minus 2, so 238. Okay, do all of those make sense? You get that? So these are types of things that we did previously. We did it when we talked about fundamental theorem. All right, now the other thing you might have is you might have like a velocity graph. Okay, so if I have a velocity graph, and I want you to find, and I tell you that s of 0 is equal to 5, and I want you to find s of 3, how do you find that? I know I have no numbers on there, but how would you find it? You'd find the area of whatever that trapezoid is, right? So let's say the area in here was 5, and the area in here is 4. Okay, s of 3 then would be, you would start with, or you'd have 5, but then you would also need to add in that other 5, okay? So this is where it gets a little bit confusing for students when they have that initial position, because here's what's happening. If you integrate v of t from 0 to 5, or what was I finding? S of 3, right? 0 to 3, what you're really doing is you're finding the position at time 3 minus the position at time 0. So in other words, you're finding that area represented on the graph by that trapezoid, but you're adding the s of 0 over to it. So this was 5. And the s of 0 was also 5. So your position at time 3 ends up being 10. Do you guys see what's happening? So you're finding the displacement, which was 5, that was found from the trapezoid, and you're adding that initial position. A lot of times your initial position is 0, so it's not a big deal anyway. But just kind of know that that can happen. What if I asked you s of, we'll make that 6, s of 6, position at time 6. So you don't have to write out all the integral stuff. Okay, what's the total displacement from time 0 to time 6? Close, not negative though. 1 unit, right? Does that make sense? Because you have positive 5, you have negative 4. Do you guys see it? So you have 1 unit. So if you started at 5, like you were already over at 5, and you have a displacement of 1 after 6 seconds, where are you going to be? Yeah, you're going to be at 6. Does that make sense? You take your initial and you add on the displacement. Do I see confused faces, or you guys totally get this? Thumbs up?
Still add 5 to it.
Yeah, so that's what I was saying. Like, you would take this 5 from here, and you take the 4 from here, so you'd have 5 minus 4 is your displacement. So that's the displacement for first 6 seconds or whatever, 6 minutes, whatever it is.
Did you add?
Yeah, so you have to. In order to get s of 6, you have to add, so plus initial position. So your s of 6 is actually 1 plus 5, which is 6. Okay? And you could write that out with the integral. I think it would make more sense if you write it out with the integral, right? So if you write all of it out, you'd say, okay, I want to find s of 6. So I'm going to integrate my velocity function from 0 to 6. That's going to give me my s of 6 minus s of 0. So basically, you're just taking your s of 0 and you're adding the displacement, right, which was 5 minus 4, to get that total. Okay, so if you write it out with the integrals, I think it makes a little bit more sense. But All right, so I kind of wanted to give you that little background info before you start this homework.